Hey, hi, and welcome back. I hope that you are enjoying this training. Also, I hope that you are learning a lot of valuable things, okay? And I assure you, you will learn even more valuable things in the upcoming video, okay? So that's my promise. All right. So in previous video, I gave you the brief introduction to the Atmega 328 microcontroller. And in this video, we will discuss its pin configuration, okay? And again, this particular video is going to be very important from circuit design point of view. So listen to this video carefully. All right. So that being said, now let's start with this video. So now let me tell you what you will learn in this video. You know, whenever we want to use any controller or whenever we have to create a design based on any controller, at that time, we should know its pin configuration or pin map, okay? Because you know, we can't create a design using a controller without knowing its pin configuration or the functionality of its pin. That's the reason I have actually dedicated this video to the pin map of Atmega 328 microcontroller. And in this video, we will try to understand the functions of all the pins which are there on this Atmega 328 controller. Okay. So that's basically the learning objective of this video. The first point is understanding microcontroller's pin map. And the second point is understanding functionality of all the pins. All right. Now, one thing that I want to clear here is if you are dealing with the microcontroller for the first time, then there will be actually multiple terminologies in this video that you will learn for the first time. So you don't need to get confused with them because it's obvious if you are dealing with something for the first time, then you will have a lot of confusions regarding it. Okay. But you don't need to bother about it. At this moment, just listen to this video carefully and consider those terminologies as a granted. Okay. And gradually over the period of time or in this training, gradually, all those terminologies will get clear to you. All right. So I hope that this is clear. Now let's start with this video. So this is basically the pin configuration of Atmega 328 microcontroller. And I have taken this pin configuration from the datasheet of Atmega 328 microcontroller. So you just need to go to the pin configuration section and you will find this particular pin configuration image in that section. Now again, this particular image is not colorful in the datasheet. It is just the black and white image. I have given multiple colors here in this particular image just to explain you or just to segregate the different pins of this microcontroller as per their functionality. Okay. So it will be a lot easy for you to understand the different pins which are present on this controller. And along with that, it will be a lot easy for me to explain the different pins which are there. Okay. So there are actually total 32 pins in this controller, and the controller that we are using, which is Atmega 328, it has got TQFP 32 package. So 32 actually represents the number of pins, and this is actually the name of the package that we are using. And you can see on this side there are actually 8 pins. So all the controllers that you will see in the market, they are going to be symmetric. So most of the time, the pins are going to be equally divided on the each and every side. So here there are 8 pins. So there are total 4 sides. That's the reason there are total 32 pins in this microcontroller. Okay. And on actual Arduino Uno board, there is actually a DIP package, which stands for dual inline package of this controller. And in that particular controller, you will find just 28 pins. Okay. So there are actually 4 extra pins in this particular controller with this package. Okay. So now let's try to understand the pin configuration of this controller with the help of this information that I have given here. So we will go through each and every information step by step, and with this information, we will try to understand the pin configuration and the different functionalities of those pins. Okay. So I'm not actually going in much detail about the different peripherals which are present in this microcontroller. Just to give you a brief overview, whatever information is important, I'm just going to discuss that information in this video. Okay. So the first point is total pins. There are actually 32 pins in this microcontroller, about which I have already discussed, as this is a TQFP32 package. So there are actually total 32 pins in this package. Okay. And these 32 pins are actually divided in this format. So there are actually 23 port pins or 23 GPIO pins. So GPIO actually stands for General Purpose Input Output. So you can use these 23 pins as output pins. You can use these 23 pins as an input pin. So, and after that you can use these 23 pins for general purpose, okay, which also means for special function. Now in this controller you will see that multiple pins have multiple functionality. For example, this particular pin has got ADC2 and PCInt10. So this particular pin has got multiple functionality, and these are actually the special functions which can be executed by this particular pin. So you can use this particular pin as a output pin. So when you configure this particular pin, when you write the code and you configure this particular pin as an output, then you can generate logic 1 or logic 0 or any kind of signal on this particular pin. And again, if you configure any of the pin of this type as an input pin, then you can read logic 1 or logic 0 or any kind of digital signal on this particular pin. And when you configure this pin for special function, like for ADC2 and this PCInt10, in that case you can, this particular pin is actually going to execute the functionality corresponding to these functions, okay, ADC2 or PCInt10. So about this I'm going to discuss in a moment. So there are total 23 GPIO pins, and port actually stands for port is actually nothing but the register. So inside this microcontroller there will be register. I'm not saying register, okay, I'm saying register, okay. So inside this microcontroller there will be register, and that register is actually nothing but the port. So at this moment, just to reduce the complexity, you can consider these pins as a GPIO pins, okay. After that there are actually total 6 pins. So there were total 23 GPIO pins were there. Then there are total 6 power pins. So I will show you. You can see here I have actually highlighted these pins in yellow color. So VCC, ground. So these are actually the pins, power pins, and using these pins we power the digital section of this microcontroller. So this microcontroller is going to have digital section, and along with that it's going to have the analog section. So using these pins we actually provide the power, or the digital section is going to consume the power from these pins, and analog section of this controller is actually going to consume the power from this pin, which is AVCC and ground, okay. So these are actually 4 pins, and then after that these are 2 pins. So these are the power pins of this controller, okay. So I hope this is clear. After that the next pin is A ref. So you can see this is actually the A reference pin, and when we deal with the analog section of or the ADC section of this controller, at that time we need to deal with this particular pin which stands for analog reference pin. But in our case, in our application, we are not using this particular pin, so let's not go in much detail. But just for the information, remember, whenever the controller uses the analog section which is ADC, about which I'm going to talk in a moment, at that time this particular pin is actually used. But in our case, we are just going to keep this particular pin in floating state, or we are not going to connect this particular pin anywhere, okay. Then the next pin is ADC6, and after that ADC7. So 23, then 6, that becomes total 29, then this becomes 30, and then 31 and 32. So I will show you the ADC6 and ADC7. So you can see this is actually, this pin number 19 is highlighted here in yellow color. So this is ADC6 and then ADC7. Now what is ADC? ADC actually stands for analog to digital converter. So whenever you have to read the analog signal from the external device, at that time we actually use the ADC pins of this microcontroller, okay. So with the help of this pin you can read a signal which is varying between 0 to 5 volt, okay. So you can also read a signal from 0 to 2 volt, 0 to 2.2 volt, or 0 to 3.3 volt. It's completely fine, but you can't provide an analog signal greater than 5 volt, otherwise you will damage that particular pin. So ADC6 and ADC7, these are actually, these pins are just dedicated for ADC functionality. you can't use these pins to generate the digital data. You can't generate logic 1 or logic 0 on these pins. This particular pin and this particular pin will be just used for analog to digital conversion. Okay, so whenever you have to read the analog data from the external interface or external sensor, at that time you can use this pin ADC6 and ADC7. So likewise, there are multiple ADC pins in this controller about which I'm going to discuss in a moment. So that's how basically total 32 pins are divided in these pins. I hope it's clear. Now here you can see I have written port. So we discussed that there are total 23 port pins are there, and these pins are actually divided in different ports. Okay. So in this controller, there are actually 3 ports. Port B is there, port C is there, port D is there. And port B is actually divided in different pins. So starting from PB0 to PB7, there are total 8 pins in this microcontroller which belongs to port B. So I will show you now the port B's 0 to 7 pin. So you can see this is the 0th pin, then 1st, 2nd, 3rd, 4th, 5, then PB6 and PB7. So these are total 8 pins of port B, and these are nothing but the general purpose input output pins, and you can use these pins for special functions like ADCs also. Okay, or it will be actually given in front of that particular pin what special function it can execute. Okay, I will talk about that in a moment. So these are actually starting from this point, PB0, PB1, PB2, PB3, PB4, 5, PB6 and PB7. These are pins of port B, and then I will show you the pins of port C. So starting from PC0 to PC6, these are actually the total 7 pins. So I will show you that now. So PC0, PC1, then PC2, PC3, PC4, PC5, PC6. These are total 7 pins of port C. And again, you can use these pins for as a GPIO pin. You can use it as an input pin. You can use it as a use these pins as an output pin, or you can use also these pins for general purpose. Okay, for special function. And after that, now the last port is port D, and again this particular port includes a total 8 pins. So I will show you the port D's pin now. So PD0, PD1, PD2, then PD3, PD4, then PD5, PD6, PD7. So these are actually total 8 pins of port D. Now you will observe that these pins are not actually continuous. Okay, it's not like they are in a sequence. Some pins will be here, then some pins will be here, some pins will be here. So this is actually as per the the internal structure of this particular IC. And based on whichever pin is close, they generally use that particular side to connect that particular pin. Okay, so that's how if you add these port pins, then you will find that total is 23. So that's how basically becomes the 23 GPIO pins. Okay, now let's see the different features which are there in this controller. So we saw that there are total 32 pins, and the package that we are using, it's TQFP32. We saw that total there are 6 power pins. These are 4 pins, and then these are 2 extra power pins for analog section. We saw that total 23 GPIO pins are there, and I also showed you all those GPIO pins starting from PB0 to PD8. After that, the next feature is 23 PCINT pins. So PCINT actually stands for pin change interrupt. Now what exactly that means, I will discuss about this in a moment. So whenever there is a change in logic on a particular pin, the interrupt routine will be called. Now you will not have an idea about interrupt routine, so I will not go in that much detail. But just remember that whenever there is a change in logic on any of the GPIO pin from 0 to 1 or from 1 to 0, the interrupt will be called. And for example, let's say that there is a main code which is executing the LED with a delay of 500 millisecond. So controller will leave that particular code and it's going to execute a separate code which is actually written inside the interrupt. Okay, so with the help of this particular functionality, you can interrupt the code, and the controller will stop executing the main code and it's going to execute the another code which is written inside the interrupt routine, okay, or you can also call it as interrupt function. Okay, so now I will show you the total 23 PCIe pins. So generally all the GPIO pins that we saw, those all GPIO pins actually supports the pin change interrupt functionality. So I will show you PCIe 0, 1, 2, 3, 4, then 5, then 6 is here, then 7, then 8, 9, 10, 11, 12, 13, 14, 15 is not there, 16, 17, 18, 19, 20, 21, 22, 23. So that's how basically 23 PCIe pins are there in this controller. So you need to tell the controller by writing the code that I want to use this particular pin of this microcontroller as a special function which is PCIe. So all those things will be done using the programming. Okay, so these special functions will not be the default which will be executed by this controller. You need to tell the controller that I want to use the special function which is supported by that particular pin through the code, and then only that particular special function will be executed. Okay, then the next feature is two external interrupt pins. So I will show you. So this is actually the external interrupt pin INT0 and INT1. Now there is actually not much difference between the PCInt and external interrupt. In case of PCInt, the interrupt will be generated whenever there is a change in logic. But in case of external interrupt pin, when you provide this kind of signal, the interrupt will be generated obviously whenever there is a change in logic, and also the interrupt will be generated on the rising and falling edge. So that extra functionality or that extra feature is actually there inside, that actually comes with the external interrupt. So you need to tell the microcontroller whether you want to receive the interrupt on the change in logic or whether you want to receive the interrupt on the rising and falling edge. So that you have to tell through the programming. I hope this is clear, external interrupt. Then the next feature is 8-channel ADC. 8-channel means nothing but the pins. 8 separate pins are there in this controller, and using those 8 separate pins, you can actually read 8 analog sensors which you have connected to the microcontroller. Okay, so I will show you 8 ADC pins of this controller. So ADC 0, ADC 1, ADC 2, ADC 3, 4, 5, 6 and 7. So total starting from 0 to 7, there are total 8 ADC pins, and you can use these pins to read the analog data starting from 0 to 5 volt. I hope it's clear. And this 10-bit actually represents the resolution. So higher the number of bits supported by the ADC, higher will be the resolution of that particular ADC. It's going to measure, smallest change in the value. Okay, so if you have a 8-bit ADC, then the accuracy of that particular ADC will not be that much. If you have a 12-bit ADC, then the accuracy of the readings that you will read from the sensor, it will be even higher. Okay, so this topic is actually very important, and at this moment I'm not going in that much detail. Okay, there is a lot of theory behind it. So at this moment you just remember there are total 8 ADC pins in this controller, and it supports the 10-bit resolution. Then the next feature which is supported by this controller is USART. So these are actually the pins of USART interface, RX and TX. USART stands for Universal Synchronous Asynchronous Receiver Transmitter. This is actually the communication interface, and you will find this communication interface in almost all the controllers. Okay, in 8051 controller this interface is there. Yeah, it's there in the 8051 controller, and in most of the controller you will find this particular interface. This is actually very basic interface. Okay, and there are two pins in this interface, RX and TX. So whenever you have to do the communication with an external device with support USART interface, at that time you can use the USART pins of the microcontroller. Okay, so you will connect the USART pins of the microcontroller with the USART pins of the external device which you have connected. Okay, for example, GPS device, GPS receiver which are available in market, it supports the USART interface. So what you can do, you can connect the pins of microcontroller directly to the GPS USART interface of GPS module, and you will get the coordinates of your location, okay, or you will get the location, or you can this GPS, you can actually read the data which is sent by this GPS with the help of this microcontroller. Okay, so I hope this USART interface is now clear to you. Now let me show you the pins of this USART interface. So PD0 and PD1, these are actually the pins of USART interface. You can see RxD and TxD. So whenever controller has to send the data, it will be sent over TxD pin, which is transmit data pin. And whenever the controller has to receive the data, it will be received over this pin, which is RxD pin, which stands for receive data pin. Okay, I hope this is clear. So that was all about the USART interface. Then the next interface is SPI interface. So SPI actually stands for Serial Peripheral Interface, and these are actually the pins of SPI interface: MOSI, MISO, SCK, and slave select. MOSI stands for Master Out Slave In, MISO stands for Master In Slave Out, and SCK stands for serial clock, and slave select, which stands for SS. So like USART interface, again this is actually another interface. Every interface which will be there in the controller, they have their own advantages. For some cases we use USART interface, and some cases we actually use SPI interface for the communication. So like we discussed, in case of USART interface, there will be again some devices which supports SPI interface. So you just need to connect the pins of the appropriate pins of the microcontroller with that particular device. For example, let's say that if you are using of external flash memory, then you just need to connect the pins of this microcontroller to the appropriate pins of the flash memory IC, and later you can do the communication between you can actually perform the communication between two different devices. Okay, for that you will have to write the code. So that's basically the SPI interface. Now let me show you the pins of SPI interface. So here are the pins of SPI interface. This is slave select, then MOSI, Master Out Slave In, MISO, Master In Slave Out, and after that SCK. So I hope this is clear now. So SPI interface is actually another interface which will be there in the almost every controller. In case of 8051 controller, this particular interface is not there because 8051 controller is actually very old. Okay. Then the next interface is I2C interface or TWI. TWI stands for two-wire interface. Okay. And I2C stands for Inter-Integrated Circuit Interface. So both are actually same. Whenever we deal with the microchips, Atmel's controller, at that time you will actually use this particular word, which is TWI, which stands for two-wire interface. Okay. So there is actually a big reason why Atmel controller includes this particular interface, and why it do not call this interface as I2C. But from working point of view, both the interfaces are actually same. Okay. In most of the controller, almost every controller, you will find this I2C interface, and only in case of Atmel's controller or Atmega series controller, you will find this particular interface, which is two-wire interface. Okay. But from functionality wise or from working wise, they are almost same. Again, in 8051 controller, you will not find this I2C interface. Now these are actually the pins of I2C interface: SCL, which stands for serial clock, and SDA, which stands for serial data. So like we discussed, in case of USART and SPI, again there will be some devices or some ICs which works on I2C interface. So in that case, you just need to connect the controller pins to that particular device, and later you can do the communication with that particular device. So USART, SPI, and I2C, these are actually the communication interfaces, and based on the application or based on the IC or external module that you are using and the different interfaces supported by those modules, you have to select the appropriate interface in order to communicate with those modules. Okay. So now I will show you the I2C pins on this microcontroller. So PC5 and PC4, these are actually the I2C pin. You can see SCL and SDA is given here. After that, now the next, this is not interface. This is actually the functionality, which stands for pulse width modulation. So there are actually 6 pins on this controller which supports a PWM feature. So I will show you which are those pins. This is basically the first pin, OC0B. So wherever I have highlighted with the red color, these are actually the pins which supports PWM, which stands for pulse width modulation. So pulse width modulation is actually a feature using which you can generate the analog signal on with the help of microcontroller. For example, if you want to generate a 2.45 volt with the help of microcontroller, then you can use PWM. Again, if you want to generate 3.3 volt with the help of microcontroller, then you can use this particular feature. So you need to write the code, and based on the way you have written the code, you can actually generate the appropriate voltage on the respective pin of the microcontroller. Okay. So this is the first PWM pin, then this is the second one, third, fourth, fifth, and then sixth one. So these are 6 PWM pins of this microcontroller. Then the next one is analog comparator. So these are actually the pins of analog comparator. You already know, you might have learned the op amps. So we use the op amp in the comparator mode. So in the same way, there is actually a comparator inside this microcontroller, and you can use these pins of this microcontroller in comparator mode. Okay. And after that, the 2 pins are there for crystal oscillator. So you can connect an external crystal oscillator to this microcontroller in order to provide the clock to this microcontroller. Okay. Otherwise, controller will not work. Then the last pin is reset pin. So you can see this is actually the reset pin of this controller. And above that reset pin, you can see there is one bar which actually tells that this particular pin is active low. So when you connect this particular pin to the ground, because of that, the controller will be in reset state. It means that if you have programmed a code inside the microcontroller, then controller will not execute that particular code. Okay. Because you have connected this particular pin to ground. And when you release this particular pin, and when you connect this particular pin to a logic high or VCC with the help of appropriate value of resistor R, then this particular controller will not be in reset state, and it's going to execute the code which is programmed in this controller. Okay. So that was all about the pin configuration of this microcontroller. I hope that every single thing that we discussed in this video regarding the pin configuration of Atmega 328 is now clear to you. And if you still have any kind of doubt, then definitely you can reach to me and I will help you with that. Okay. Alright, so that's what I wanted to tell in this video. Now I will see you in the next video, which is about Introduction to Microcontroller Part 3, Pin Map Comparison with Arduino Uno. So I will see you in the next video now.